Today we will be seeing how to solve pfaffian differential equations. Already we had discussed the first method, that is the method of inspection. That is, if you are given a pfaffian differential equation, we might be able to find an integrating factor with the help of which we can solve the differential equation. Now this is the second method, and second method is called variable separable. As in the case of ordinary differential equation, the same meaning is the same. If you can separate the variables, then definitely the integration is going to be easy. The pfaffian differential equation of that form will be p of x into dx plus q of y into dy plus r of z into dz is equal to 0. It's clear from the format that along with dx you have functions of x alone, which is px. Along with dy you have functions of y alone, and along with dz you have functions of z alone, so that the integration is easier. Now let's suppose consider a question. This is the question: a square y square z square dx plus b square z square x square dy plus c square x square y square dz is equal to 0. In first side this is not variable separable, but we'll have to try whether you can turn it into a variable separable form. If you check over here, along with dx you have y square z square, but x square is the term which is missing. Here also y square is the term which is missing. Here z square is the term missing. Let's try in dividing the full equation with x square y square z square. So we are going to divide the full equation by x square y square z square, which will lead to a square by x square dx plus b square by y square dy plus c square by z square dz is equal to 0. Now this is of the form variable separable, because along with dx you have functions of x alone, along with y dy you have functions of y, and along with dz you have functions of z. Okay, now this is easily integrable. When you integrate this, you will get minus a square by x minus b square by y minus c square by z is equal to an integrating constant c. You can take over the minus from all the sides, so the final answer can be written as a square by x plus b square by y plus c square by z, which is minus c, which can be again written as another constant c1. So this will be the final answer. Now let's see the second method. Third method. The next method is one variable separable. That if the pfaffian equation, differential equation is of the form p of xy dx plus q of xy dy plus say some r of z dz is equal to 0. In this case, along with dz we have function of z alone. That is, that variable is separable, but the dx and dy is intertwined. They have all kinds of variables including x and y. So this is the variable which is separable, and this is the portion which is not separable. Let's see how we can solve such kind of equations. In this kind, always remember that whenever you are given a pfaffian differential equation, if you need to find a solution, definitely the pfaffian differential equation should be integrable. And how do we check whether the equation is differentiable? We have the theorem that a pfaffian differential equation is integrable if and only if x dot curl x is equal to 0. So whenever you start solving a pfaffian differential equation, always make sure that the pfaffian differential equation is integrable by computing x dot curl x is equal to 0. And remember that x, the vector x, is given by the functions p, q and r. Let's try what happens in this case, p, q and r. Now this is my x, and if I am going to compute my curl x is I, j and k. I need a p of, let me write p itself. It's clear that p is a function of x and y alone. P, q, this is curl x. So my second row should be dou by dou x, dou by dou y, dou by dou z, p, q and r. Let's compute this curl. When you compute this curl, we'll have I into, if you just try here, this r is a function of z alone. So when you are taking the derivative with respect to y, you will get a 0. Okay. Again, with respect to minus j, when I am taking this column, this row and this column, I will get again the same situation comes. With respect to x, when I differentiate, I will get 0. Similar is the case with p when I differentiate with respect to z. So this is again 0. I will be left with the third vector part alone, that is the k part, z along the z axis. Now here I will get a value, that is dou q by dou x minus dou q by dou x minus dou p by dou y. Okay, so my curl x is, if I am writing in the component form, this will be 0, 0, dou q by dou x minus dou p by dou y. And we say that a pfaffian differential equation is integrable if and only if x dot curl x is equal to 0. What happens if I am taking x dot curl x? If I am taking the dot product, this would imply that this is my x in p into 0, 0, q into 0, 0. So the last term remains, r into this term must be equal to 0. Definitely r cannot be equal to 0 because we have already said it's a function in Z. If it's 0, then definitely there is no pfaffian differential equation of free variables. So r cannot be 0. Definitely the next part would be the kth coordinate, that is this term should be equal to 0. That is dou q by dou x minus dou p by dou y must be equal to 0 for such an equation to be integrable. Now what is dou q by dou x minus dou p by dou y? We know that p is a function of x and y, q is again an exponent of x and y. So just consider this much of the equation, that is the first and second part. So what we are trying to say here is, if this partial differential equation is to be integrable, considering this part, this much part should be an exact differential equation. Just try. This is dou q by dou x minus dou p by dou y equal to 0, which implies dou q by dou x should be equal to dou p by dou y. That's the same as our condition for exact differential equation. So whenever one variable is separable, the remaining coefficients, that is dx and dy, the coefficients of dx and dy should be such that that part should be an exact differential equation. Now if the case is different, let's try if what happens in the case when this portion, that is y, is separable. When y is separable, we have here and here. Okay, now the p of x z dx plus r of x comma z dz should be a exact differential equation for such type of equations to have a solution, that is for them to be integrable. Now let's try how we can do such kind of problems. Consider the question, x into y square minus x square, y square minus a square dx plus y into x square minus z square dy minus z into y square minus a square dz is equal to 0. Now let's see. It's definitely this is not variable separable, but let's see if we can make it into a one variable separable form. If you check the first term and the last term, you have y square minus a square to be common, and in the second term, middle term, you have x square minus z square. Now let's try dividing the whole equation by x square minus z square into y square minus a square. So I am dividing the full equation by y square minus a square into x square minus z square, so that the first term will become x minus x square minus z square dx. The second term would be y by y square minus a square dy minus z by x square minus z square dz is equal to 0. Now the second term has automatically become separable. So second term is separated. We have first term and the last term remaining. Let's group them together. This would be first and the last term. When I group together, I have the common denominator, so that x dx minus z dz divided by x square minus z square plus y by y square minus a square dy is equal to 0. Now this is my pfaffian differential equation, the transformed pfaffian differential equation, if you wish to call that. So now this is the format. And for the pfaffian differential equation, such kind of pfaffian differential equation to be integrable, we have already seen that this portion should be exact differential equation. Now let's try whether this is exact. Exact in the sense, now my dou p by dou z should be equal to my dou r by dou x. Whether this happens or not, we have to check. Let's check it out whether that is the case. So when I do that, dou p by dou z would give me minus 2zx dx by minus 2zx by x square minus z square the whole square. And when I do dou r by dou x, I'll have minus 2xz by x square minus z square the whole square. Now dou p by dou z and dou r by dou x are the same, so that the given pfaffian differential equation is integrable. Now we have to integrate. When we integrate, there's no confusion in the last term because it's readily integrable. Y square minus a square, if you substitute y square minus a square as t t, u, anything what you wish to call it, y square minus a square, let me say it's t, then 2y dy is equal to dt, so that this term would become dt by 2t, which is 1 by 2 into log t when you integrate. That is 1 by 2 into y square minus a square. Same is the situation over here. If I substitute x square minus az square as, say, some other variable u, then this is u, my du would be 2x dx minus 2z dz. This is 2 into x dx minus z dz. This is the numerator over here. So my this fraction would become 2 du by u, which is again logarithm. We have already learned that whenever the derivative of the denominator is in the numerator, then the integral will be of the logarithmic format. Okay, so now when I integrate here, I'll be getting, so here the denominator's derivative is in the numerator, so definitely I'm going to have a 1 by 2 log of x square minus z square plus again a 1 by 2 log of y square minus a square is equal to, say, some log c. Okay, now I have that. Now this would be, can take over the 2 to the other side, taking off the logarithms. I have x square minus z square into y square minus z square is equal to some capital C. That would be my final solution. Okay, let's see the next method. Now coming to the fourth method, we are going to see how we can integrate a pfaffian differential equation, which is an homogeneous equation. Homogeneous in the sense the powers of x, y, z which are appearing in the equation should be same. Now for that, an ordinary differential equation, you know what the method is. Usually we substitute y is equal to vx and do the rest of the thing. Same is the method over here. The only thing is we have to substitute for y and z. We are substituting y is equal to ux and z is equal to vx. Okay, these are our two substitutions. When you substitute this, definitely dy and dz are also going to be substituted. Now after you substitute, we have, what we have to do is we have to take the term, highest occurring term, power of x from the whole three functions. So say that is n, that is the homogeneous equation of degree n. Then I am going to take x raised to n outside from the p, q and r, so that reducing the form, we'll get into the form of this kind, dx by x plus a of u v du plus, that is a function of u and v, again a function of u and v, dv is equal to 0. After substitution and after cancelling out all the terms of the greatest power x raised to n, we'll have, this is what we are going to get. Now this is of the third method. Here we can apply the third method because it's one variable separable. Then you remember that this much part should be an exact differential equation for the pfaffian to be integrable. So if the pfaffian is integrable, definitely this is going to be an exact differential equation which can be easily solved for u and v. After getting u and v, you will have to substitute the reverse of that u should be substituted as y by x and v should be substituted as z by x to get the final solution. Let's try out an example. This is our question. Y is into y plus z dx plus x z into x plus z dy plus xy into x plus y dz is equal to 0. This is a homogeneous differential equation, pfaffian differential equation, because all the powers of x, y, z are homogeneous. And we are going straight to the method. The question is actually verify this is integrable and solve the equation. Verification is always an easy process. You have to just do x dot curl x is equal to 0. That I'm not going to do. You have to try by yourselves. Just try x dot curl x is equal to 0 or not. If it is so, you can find a solution. And this is a homogeneous equation, so we apply the fourth method. Fourth method, what we have to do is we have to substitute y is equal to ux. From here we'll have dy is equal to u dx plus x du. And we substitute v is equal, z is equal to vx, and from here dz is equal to v dx plus x dy. Now we have our y, dy, z and dz. All these things goes into our first equation. Let's name this as our first equation. Now correspondingly our first equation will become, here you have ux into vx, that is x square into u plus v into, instead of y plus z, I am having another x here, x ux plus vx. So I am taking that x also outside, that so that this x square becomes x cube into, again u plus v, got a mistake over here, this is x cube into uv into u plus v, because here it was y z, it's my mistake, x square into uv it should have been. uv into u plus v, dx is the same, dx remains intact, dx plus x, I have nothing to substitute, x here, instead of z I'll put vx, so that this is x square into v. Now again x plus z is vx, so I'll have a x to be taken outside, so this becomes x cube, and inside the brackets I'll have 1 plus v, and instead of dy I'll be having u dx plus x du. Okay, so much for the second term. Now coming to the third term, again I'll be having an x cube, because you can still see the pattern over here, I'm having x cube here, so definitely I'm going to have an x cube over there, and instead of y I'll be having a u, because that x would have already gone to x cube, so I'm having a u over there. Instead of y I'm substituting, again x would have already been taken to the x cube, so 1 plus y was u, so u into, instead of dz I'll be having v dx plus x dv equal to 0. Okay, so much for the substitutions. Now let's cancel out the x cube and try compiling all dx together, du together and dv's together. Okay, so what I have done here is I have taken off the x cube in this step. I have taken off the x cube from all these three terms, so that leaves me with this step. Now in the second step, this step actually what I have done is I have grouped all the terms with the dx. So from here you have uv into u plus v coming over here. From here, from this term you have uv into 1 plus v coming, and from the third term you have from this term you have uv into 1 plus u dx. Okay, I've grouped all the rest of the terms together, that is du and dv. For du I'm having xp into 1 plus v, that comes over here. For dv I'm having xu into 1 plus u, which comes over here. Okay, now if you see I am having uv over here, for three terms I am having uv, I am taking that uv outside, definitely uv into dx outside. Inside I'll be having a u plus v from here, 1 plus v from here and 1 plus u from here. So if I'm adding that together, I'll be having 2 times u, 2 times v and 2 times 1. So I'm taking a 2 outside over here. These terms remains as it is. So in the there's only change in the first term in this step. 2 uv into u plus v plus 1 dx plus xv into 1 plus v du plus x into u 1 plus u dv is equal to 0. Now what I'm going to do is I have to make it one variable separable, right? So what I'm going to do is I am dividing the whole equation by x into 2 uv into u plus v plus 1. Okay. Now this is what we get from here. As we have seen before, this term should be an exact differential equation. For the solution to be integrable, this would be an exact differential equation. You can follow that method. You know how to solve an exact differential equation to get an answer. I am showing you another method, that's by by separating it into partial fractions and doing the integration as usual. Taking the first term, v into v plus 1 divided by uv into, I am just avoiding the 2 over here, uv into u plus v plus 1. I have written this as a by u plus b by v plus c by u plus v plus 1. Now as usual we find the value for a, b and c. Now this is the equation what we get over here. I'm putting for the first step I am putting v is equal to 0. So this side would be equal to 0. A goes and C goes. Remaining term will be bu into u plus v plus 1 is equal to 0, which would imply b is equal to 0. So I have got my b as 0. Now I am trying to put v is equal to minus 1. When I do that, what I am getting is minus au minus cu is equal to 0. That would imply a plus c is equal to 0. Now let's try and put some v is equal to 1 and see what equations we will get for a and c, and from there we can solve for a and c. Okay. Now we will get a is equal to 1 and c is equal to minus 1. So substituting here, this first fraction will become 1 by u minus 1 by u plus v plus 1 du plus 1 by 2. Similarly, you can do this portion also. There also you will get 1 by v minus 1 by u plus v plus 1 into dv is equal to 0. I am multiplying this 2 over here, cross multiplying and removing the 2 from there. So 2 dx by x plus du from here, du by v plus from here dv by v minus from here I will be having, I can add these two things together because the denominator is same, du plus dv by u plus v plus 1. Now the integration is quite simple. You will have 2 log x plus log u plus log v minus, if you watch over here, this is the here you will have the derivative of the denominator is over the numerator. That means you will get a log over here. If you have confusions in doing that, the simplest method is you substitute for u plus v plus 1 as some t or something and just try differentiating. There you will get du plus dv is equal to dt. Then this will be dt by t, which is again will give you the logarithm format. Okay. So from here I will get the solution as, this will be 2 times log x plus log u plus log v minus log of u plus v plus 1 is equal to, say, some logarithm of c1 or something. Now this will be, I am taking off the logarithms from both sides. This is x square uv by u plus v plus 1 is equal to c1. Okay. Now that will be x square uv equal to c1 into u plus v plus 1. Now the solution is not over yet. You will have to replace u and v by the previous values. That is, u will be y by x. Wherever you have you have to replace it with y by x, and for all v you will have to replace it with the z by x. Hence the solution after the substitution and clearing of the denominators, what you will get as answer will be, the answer would be here, let me write it over here. Our answer will be x y z is equal to c into x plus y plus z. Probably we'll be getting a c1 over here because I have substituted c1 as the arbitrary constant. So my answer will be x y z is equal to c1 into x plus y plus z. Okay.